Thank you. Welcome to Reducing Loan Risk Using Data Analytics, presented by Project Group 5, including Kenji, Venkatesh, and Timothy. Our group chose to look at the lending data from the Lending Club to see if we could solve the business problem of maximizing profit, improving over the existing model's data. After a loan is approved, Lending Club makes money provided that the borrowers repay the loan's principal and interest. Less money is made when the borrower defaults and the loan becomes charged off. Loan data from 2007 through the third quarter of 2017 was available from the website, and it was broken into 11 different sets. We found that each set of data was a little different, which complicated analysis. We wanted to see if we could find models that might have the ability to improve Lending Club's profit, and also see if we could find interesting relationships in our data sets that might help us in future attempts to build accurate models. In the end, the more accurately we could interpret the data would allow us to reduce risk in future loan activities. Understanding our data. There was a great deal to figure out before we began to create a model. First, we wanted to note we were looking at loans that had already been through Lending Club's model, so that our results were dependent on their model's pre-screening of the loans and assigning interest rates based on the borrower's loan application. It made sense to us to only look at the loans that were older, so no loan data after 2014, because we were looking at loans that had been charged off weighed against loans that had been repaid. There were 151 variables in the data sets we were looking at in this time period. And looking at the 2015 data, we found that 14% of the loans had been charged off, worth $245 million. So if we could find ways to avoid these losses, we could maximize the profit of the money Lending Club lent out. Data preparation. For this step, we spent a considerable amount of time examining missing values, outliers, combining multiple categorical values into only relevant values. To make things easier for their analysis with our analytical tool, we combined all datasets into one jump file. Response was initially sluggish due to the large number of records, so we chose a subset of approximately 54,000 records. We eliminated 9 different types of loan status to just 2 options of 0 or 1 for our target variable. This involved removing records that did not match these statuses. We examined histograms, correlation charts, we did bivariate analysis, and finally looked at the log worth values to reduce our independent variables to 25 from the original 151. After setting up a 60% training and 40% validation split, we were left with a number of records shown in the slide. This indicates both the fully paid versus the charged off amounts. Modeling. We evaluated 3 models: decision trees, logistical regression, and neural networks. Our predictive model would produce confusion matrices that would show us how often we guessed whether a loan was charged off versus whether they were actually charged off. There are a couple of important observations here. First, sensitivity corresponded to bad loans that were correctly rejected. Specificity referred to the percentage of good loans that were correctly accepted. Since there's generally a trade-off between sensitivity and specificity, we looked at the average cost in 2014 of a failed loan and compared it to the profit of a good loan. The cost of a failed loan was about $6,100, and the profit of a good loan was about $2,500. Thus, optimizing for sensitivity seems appropriate in the above models. Evaluating results. How did we do? Based on profit, we evaluated the models we had created, and the best profit was associated with the neural network model, which would have saved $495,000. The logistical model did pretty well with an estimated savings of $440,000. The decision tree model actually lost $3 million. Important observations of our modeling results included: our models generally break even on short-term loans. Our models discovered that there was a much better profit on long-term loans. And note, results aren't final. More loans are still pending maturation. More profit will occur then. Overall, the logistic regression model is generally the best performing model, but neural network has the best validation statistics. Evaluating patterns. The log worths from logistical analysis bring some interesting insights into loan data. As we discussed, longer terms had a higher chance of being charged off, but also had higher profit. Interest rates correlated to charge-offs, and this would be expected, since borrowers would be paying more based on the risk of their credit application. The number of trades opened in the last 24 months and the debt-to-income ratio similarly correlated to a higher number of charge-offs, and the extent can be seen in the log worth graph on the slide. It is also important to note in our evaluation variables we expected would help our models, but were found not to help. As we evaluated the 151 original variables, we selected a much reduced set that we thought would be possible contributors to our model. We were surprised that a number of these variables, shown here in red, ended up not being useful in our predictive models. We did not have time to consider every possibility, but the items such as the purpose of the loan, we thought would certainly have some correlation. But in all the cases seen here, there was no statistically significant impact on predicting charge-offs. Data mining is an iterative process, and our deployment would be the model and jump that could now be applied and possibly improve future LendingClub loan decisions. We wanted to look at what lessons we had learned and what we might do if funded to do a second data mining cycle. First, we would consider treating short-term loans differently from long-term loans, since these loans behave very differently, with different cost functions impacting profit. Next, we would want to consider predicting payment percentage rather than charge-offs, since most charge-offs had some percentage of the money paid back. Hence, not all charge-offs were complete write-offs. Next, we would want to look at the ways to make the model more conservative by raising the threshold for rejecting charge-offs. Essentially, this would have allowed us to cast a wider net, getting more customers while still benefiting from the improvement of our models in predicting the bad loans. Next, we would want to consider ensemble models that could be found by combining our existing and possible other models. We would then look at unions, intersections, or perhaps a majority rule combination of our solution sets. Finally, we could evaluate our predictive models against other data sets that were public, as well as start looking at more recent loan data from LendingClub to see if we continue to have an improvement over their existing loans. Thank you for taking the time to watch our presentation.